In this lesson, I'll discuss a very important Arduino function, digital write. So without wasting any time, let me tell you what is digital write. Now think what the name suggests. If I literally convert the meaning, it means writing digital values. So digital write is a function which is used to write digital values. So where it writes? At pins. So this function we can say is directly associated with the input outputs. Here digital values mean high or low. A digital write function can write either high or low, and where? At pins. Now after knowing the digital write function, you may ask why we need this function. Let me tell you, there are a lot of uses. Why we need digital write? Through this function, the controller on Arduino Uno board can control outputs. I'm giving you some examples. Displays can be controlled using digital write, like 7 segments, LCD 16x2, graphic LCD, etc. You can also send pulses to some devices which are compatible with it, like in switching circuits, controller sends pulses to MOSFETs, transistors. In triggering circuits, like if a smoke sensor detects a high concentration of smoke, then controller on that condition can trigger an alarm by controlling a simple output. These are few instances where a digital write is used. Now let me take you to the basic concepts of inputs and outputs. So first, think yourself as the microcontroller. When you are giving something to someone, it becomes output. I'm repeating it. When you are giving something to someone, it becomes output. When you are taking something from someone, it becomes input. So to and from are the keywords here. Similarly, when a microcontroller gives voltages to some circuits, it becomes output operation, like glowing a LED. When a microcontroller takes voltages from some circuits, it becomes input operation, like checking the status of a button, whether it is pressed or not. Unlike us, the human beings, a microcontroller can give or take voltages only. But here is a catch. When we are giving and taking our hand gestures, here comes another function, that is pin mode. Now let me explain. It defines the hands of a microcontroller to work as inputs or outputs. Here by hands I meant pins. How we write pin mode? The syntax is pin mode, M is in capital, within bracket, parameter 1, comma, parameter 2. Parameter 1 is the pin number you want to define. It can be any number from 0 to 13 and A0 to A5. Parameter 2 is the type, like you want to define the pin as input or output. So the type can be input or output in text. As a sample, say we want to define pin 9 as output. Then how we will write that? So we can write like pin mode within bracket 9, comma, output, all in caps. Here pin 9 will be giving voltages. That's it. Now similarly, digital write function is like the pin mode. We write digital write as digital write, W is in caps, within bracket parameter 1 and parameter 2, comma separated. Now parameter 1 is the pin number, same as pin mode. Parameter 2 is the value you want to write. Now see how we write it, the syntax, taking the same example 9 as output. Digital write within bracket 9 comma high. High is all in caps. When this function gets executed, then pin 9 will give us straight 5 volt at output. Mostly we use pin mode once in a program, so we write it inside void setup function. But digital write can be used anywhere and many times. To make it clear, I'll do an experiment with LED blinking. My methodology will be glowing the LED on, then a certain delay, then LED off, then again a certain delay. Delay is used because we need to make the on state and off state visible. Without delay, we'll not be able to visualize the blinking. Here, delay is the new function which generates time delay. So what is the meaning of this delay function? We send only one parameter to it, that is a value in milliseconds. Like if I write delay within bracket 1000, the function will generate a delay of 1000 milliseconds, which is equivalent to 1 second. Now let's see the circuit. Here the connections are very simple. I have connected LED at pin 12 through a 220 ohm resistor. Resistor always protects the LED from overcurrent. It is the best practice. Practically, when you are doing a project, always use a resistor. Here I'll perform the experiment for a minute or so. So I'll not use resistor in this case, but practically I recommend you to use resistor always. The anode of the LED is connected to pin 12 through resistor and cathode is connected to ground. So connection is very simple. Now let's make the circuit. Look what I have. I have Arduino Uno and this is a red color LED. Now this LED has two pins. The long one is anode. This should be connected to the positive terminal, and the short one, this pin is cathode. This should be connected to the negative or ground, and long should be connected to the positive. So I'll connect the long pin at pin number 12 and the short pin, that is cathode, to ground. So this is the simple connection. Now what I'll do, I'll connect the USB cable. Now it's time to write the code. I'll open Arduino first. I'll click on no. I don't need to download the latest Arduino. This is enough. Now I'll increase the font size so that the code is clearly visible to you. Now I'll increase the font size. Oh, it's Control plus. Now it is clear to you, I guess. I'll define first the LED pin, and LED I have connected at pin 12. So LED is equal to 12. So in pin mode, I'll define LED that is equivalent to 12 as output, because I'll give voltage to the LED. Now I'll write digital write within bracket LED, comma, high. These notifications you can cross that. These are the update notifications. Now LED high, then I'll put a delay of a second. Then again digital write within bracket LED low, and again a delay. The delay will help you to clearly visualize the blinking. Now as I have written the program properly, let me repeat the code. I have defined LED at pin number 12. Then in pin mode, inside void setup, I have make the LED pin as output. Then inside void loop, I have written digital write within bracket LED high, delay of a second, then low, then again delay of a second. Simple program. Now I'll save the program. Let me save it. Here I have already created a folder called Arduino course. Inside that, digital write. I have saved. Now I'll check the Arduino. Arduino is at port COM5. So it's connected. I'll click on upload. The uploading process will take some time. Done uploading. Now see, the LED is blinking. After a second, it glows on. After another second, it is off. Now see, if you have a stopwatch or something, you can measure that the delay is 1 second.